All right, so we're going to continue on with 1.5, which is what I'll call function arithmetic. Your suggested exercises are 5, 15, 25, 35, and 55. So the main things we're going to be dealing with are sum, difference, product, quotient of functions. Actually, let me write this as a dot. We're also going to do a very special thing called the difference quotient. And then I'd like for you to work through examples 1 and 2. In the book. So this is going to be pretty straightforward for the first part, which is just we've got a little table that we'll make here. I guess I could do it like this, right? So I've got let's see here. Should actually move this, huh? Okay, so for functions f and g, we have the following table with name, notation, and meaning. So the name is going to be sum, and the notation is f plus g of x. And what this means is f of x plus g of x. The name difference is going to be written f minus g of x, and this just means f of x minus g of x. The name product is fg of x, and this means f of x times g of x. Finally, we have quotient, not to be confused with difference quotient, and this is f over g of x, and this is f of x divided by g of x, provided g of x does not equal to 0 at that point. So this is, I think, pretty straightforward. Most of this, I think you can pick up on pretty quickly. But let's do some examples. So let's let f of x be, say, 2x plus 1, and g of x is going to be x squared, and let's let h of x, so semicolon separating these, be x minus 1 over 2. Just 3 nice little functions. Let's compute a few different things here. So let's compute f plus g of x. Let's have you compute, let's do h minus f of x. Let's do f times g of x. And lastly, let's do h over g of x. So take a second and try to work through these. I will sip some water. I already finished my tea. You might pause the video and try. All right, so f plus g of x is f of x plus g of x. And this is just 2x plus 1 plus x squared. Now I know this isn't written in ascending or descending degree, so you might want to clean it up and write, x squared plus 2x plus 1, and if you wanted to, you can factor that into x plus 1 quantity squared, but you don't have to. You can stop here and that's fine. Let's do h minus f of x, which is, of course, h of x minus f of x. Okay, so this is just x minus 1 over 2 plus 2x plus 1. Again, if you wanted to simplify that, you could. That'd be great. If you don't want to, that's also fine. Okay. Let's do f times g of x. So this is, oops, f of x times g of x. I bumped the little home key there. And this is going to be 2x plus 1 times x squared. We should probably simplify this out, shouldn't we? So this is going to be 2x cubed plus x squared. Should probably simplify this one out too, just to see it. So this is going to be what? 5x over 2 plus 1 over 2 or something like that. It's plus 1 minus a half. That's 2 plus another half x. Either way is fine. I'm not too much of a stickler about this. This is just, we're going to be using this coming up soon, so I want to make sure that we're clear on it before we get past it. And then this one's going to be h of x divided by g of x, but we need to remember here that we can't divide by 0. So whatever this is, it can't equal 0. Whatever the input x is, we need to make sure that g of x doesn't equal 0 there. So this becomes x minus 1 over 2, and we divide that by x squared. So it's this, but we also need to guarantee that x squared doesn't equal 0, and that's the same as x doesn't equal 0. Okay, so this should be in the answer as well. All right, the big takeaway here is plus, minus, and times work the same way as you would expect with functions, and division works similarly, but since we can't divide by 0, we have to be careful and just check that our g of x doesn't equal 0. Okay, so the next thing, and kind of the other big thing from this, is the difference quotient. So I'll define that. Given a function f, the difference quotient f is, and this is something that I'm defining here, and this is very important. Okay, I really need you to remember this, the difference quotient. Okay, I really need you to remember this. The difference quotient of f is f of x plus h minus f of x divided by h. This is something that you need to memorize. Okay, I don't like asking you to memorize things. This is something you need to memorize. This is that important. And if you are talking to your friends who are way further along and they're like, difference quotient, I never use that. That's because difference quotient isn't used so much explicitly as it looks. But the concept of difference quotient is going to be leaned on very heavily in calculus. And in order for you to understand the basics of calculus, you're going to need to be fluent with the difference quotient. Now you're going to have a friend that's like, oh, whatever, I just remembered the formula for derivative and it's fine, you don't need to know that. And they are right for what they're doing, maybe. You can get away with a certain amount. But that's like saying, oh man, I never learned to reverse a car, I just drive forward everywhere and it's fine most of the time. It's fine until it's not. So you should learn this now, learn it well, and then when you get to calculus, learning the concept of a derivative will be easier, and then later you can forget about it. Later, it's like training wheels. After you've learned how to ride a bike, you probably don't need training wheels. However, this concept, I guess it's not really a concept here, it's just a little dinky formula, but this relates to the concept of the derivative so strongly that if you understand this, then you'll understand the derivative better, and moreover, you'll be able to use the derivative more appropriately and more powerfully. So let's do an example. Let's do a simple example. Find the difference quotient of f of x equals, what do we have? X squared plus 2x plus 3. So this is going to be pretty nasty. I think that, I probably won't give you something quite this intense on an exam. This is fair game for a quiz, though. But I'm just going to say that this is going to have a bunch of symbols flopping around, and there's a distinct possibility that we can make mistakes here. So just want you to be aware of that. Okay, now solution. So the first thing I want you to do, the very first thing I want you to do is write the formula again. F of x plus h minus f of x over h. I just want you to write this formula. I want you to learn this formula. I want this formula to be very familiar and comfortable to you. So now I want to plug this formula in, and that's going to take a little bit of work. So what is f of x plus h? Well, it's going to be f of x, but wherever I have an x, I'm going to write x plus h. So here I have an x. So I'm going to write out f of x plus h. Here I have an x. So this x is squared. So this x squared, I'm going to write as x plus h quantity squared. So x plus h quantity squared. Now I have plus 2x, so plus 2x plus h, and then plus 3. Now this is 3 for x. What is this for x plus h? Well, it's still just 3. Okay? And this is my f of x plus h. So what I've done is I've rewritten f of x, but every time I saw an x, I wrote x plus h in parentheses. You know, it's good to stick in the parentheses. I wrote x plus h in parentheses instead of the expression x. Okay, and this is my f of x plus h. Now, let's keep going. I need to subtract f of x, right? So I subtract, and then I just write out this formula here. F of x is x squared plus 2x plus 3. Now, what am I doing wrong? What, strictly speaking, is incorrect? I just wrote f of x. I needed to write f of x. But this expression, this whole expression f of x gets hit by this minus sign. So I need to put it in parentheses just to make sure that this minus sign hits all those plus signs. Can I move on? Can I start writing down here? Can I start writing down here? Can I start? No, not yet. The number one thing that, well, I shouldn't say number one. One of the top 3 things that people forget is to divide by h. I know it's annoying. It feels like you're wasting a bunch of paper dividing by h. I just remembered that I was dividing by h. The thing is, you remember until you forget. So please just take that extra time, take that extra space, and put that you're dividing by h. This is extremely important. Okay? The formula is f of x plus h minus f of x divided by h. If you don't have all of those components, something horrible will probably happen. Okay? So now let's continue. What we're going to do is simplify the numerator and cancel some things out. So x plus h quantity squared becomes x squared plus 2xh plus h squared plus 2 times the quantity x plus h gives me plus 2x plus 2h and then plus 3. Now let's distribute this minus sign, so minus x squared minus 2x and minus 3. All of this is divided by h. We've got plenty of space, we're going to use plenty of space, okay? Now what I want to do is I want to cancel things out, and I want to cancel things out additively first. Before I start looking for h's to pop out, I want to try to get rid of the terms that cancel each other out on the top. So let me just highlight some things that are similar. So x squared minus x squared plus 2x minus 2x, okay? We've got plus 3 minus 3. So we should only be left with these 3 terms, okay? When we're done with everything, those 3 terms should be all that we have left. Okay, so let's get rid of the distractions. X squared will cancel with x squared. We saw that 2xh and 2xh and h squared and 2h didn't cancel with anything, but let's just wait. Plus 2x cancels with minus 2x, plus 3 cancels with minus 3, and now I just write down what's left, and I have 2xh plus h squared plus 2h, all divided by h. And now you see why it was so important that we had this h. Let's factor an h out of the numerator, and I have h times 2x, the h squared becomes just h now, plus 2, and I'm going to divide by h. These h's cancel, and my final answer is 2x plus h plus 2. Okay, now that was a lot, but I recommend pausing maybe going back over it and watching it. If you do already know about derivatives, if somebody has taught you the dirty secrets of derivatives, you can just check that the derivative of this is this thing if we set h equal to 0. The reason is this is an average rate of change, and the derivative is the instantaneous rate of change. So the rate of change when h goes to 0. Okay, if those words don't mean anything to you, that's fine. You don't need to know them. That's just a little checking for those of you that have seen some calculus. And that is all for today.